Hi dear friends, welcome back to my channel. I'm Gerard and I'm here to study math together with you. So in this series I'm studying quadratic. We have seen many things about quadratic equations, inequalities and so on. So we have equations, we have inequalities. Yeah, we know that when we are multiplying or dividing by a negative number like 1, so we have to change the direction of these inequalities signs. Okay, we know how to solve a quadratic equation. We can do it by factorization, completing the square, and the same for this. And if we can't do these things because it's difficult, so we can use the quadratic equation, which is, sorry, I'll just erase this. So which is something that you have seen in your life if you did math. Square minus 4ac divided by 2a. I'll put it here, 2a. This is x is equal to this. So if we want to have the value of x, and we also saw a lot of different things because this is called the discriminant. Okay, this is called the discriminant. It tells us if the discriminant is greater than 0, there are two real values we call roots for x. If d is equal to 0, there is only one value for x. If d is less than 0, there are no real roots. There are no roots. What is a root is where the curve crosses the x-axis. So if the curve is up there, there is no point where it's crossing the x-axis, and therefore the discriminant is like that. If it's crossing at 2 points, so it should be greater than 0, and if it's just touching the line, the x-axis, so it should be d is equal to 0. All right, so this is all a summary of what we've just learned, and I remember that we have complex thing. For example, if we have 6 plus x3 and so on, we want to solve this, we have to say that y is equal to x to the power of 2. So if we have y to the power of 2, so sorry, like this. So we basically have x to the power of 6. So we just substitute this, and then we can solve the problem. We can find y, and then in the end we just remember that we use this relationship, and we can solve the problem. All right, that was for complex. And so now, just to close this series, I would like to very quickly, just do an exercise. So we have seen that sometimes we have, for example, a curve and a line, and we want to know where it crosses each other. So this is very simple. We're going to have a look at this. Let's say we have an inequalities, which is like this: 6 plus minus x to the power greater than 0. So we want the value of y when it's greater than 0. So what we have to do, we have to factorize this, and I've learned that well, this one we already did it. I'm sorry. What we need to do here is something else. I'm sorry about that. Let's do y is equal to x squared minus 3x minus 1, and the line 2x minus 7. So this is a quadratic, this is a line, this is linear. Okay, so if we want to solve this, so what should we do? How can we know where these two the curve and the line meets. So we just have to equate them. We know that this is equal to this. So I will write a little bit smaller so that I can fit everything in the screen. So let me write it like that. X squared minus 3x plus 1 is equal to 2x minus 7. So now we see that it's like that. So we'll have an equation minus 2x minus 1, and this time we have plus 7 is equal to 0. So if we want to solve this, we have minus 5 here, plus 6 is equal to 0. So that's what we got, and we know how to solve this. We are just going to factorize. So how can we get 6? A times b to have 6 and a plus b to have minus 5. We know that it's going to be minus 6 here. No, minus, oh, sorry, I'm just in a hurry. I'm going to take here, so x here, have minus 6 plus 1. If we expand this, we'll have x squared plus x minus 6x minus 6, which is not good. Therefore, that's not the right root. Sometimes it's like this. We think we got it, but it's not good. So let's try another way. So how can we get 6? We can have 6 by 2 times 3, for example. And if we, let's try like that. So we have x here, and we have minus 2, minus 3. If we expand, we have x squared minus 3x minus 2x. So this will give us 5x. And when we multiply both, because they're both negative, they're going to be positive here. So therefore, minus 2 and minus 3, they do the job. So we have now found the points where the graph crosses each other. But what we want is not just this. We want also the y for when this happens. So this is very easy. So we're going to remove this. We have all this removed as well. We want only this to stay. So we know that x is equal to 2, x is equal to 3. So if we put this here, we'll get the y. 2 times 2, 7. This is 4 minus 7, gives you minus 3. So we have coordinate 2 minus 3, and we have the other one is right here. We're going to do the same. We're going to wait a second, I'm just making space here. So we're just going to throw this in this time. So we have 2 times 3 minus 7. This is 6 minus 7 or minus 1. So it's minus 1 here. Alright, so we have these points. So let's do something. We got all these things, nice things. Let's have a look at the equation once again. Was y is equal to x squared minus 3x minus 1. So here the coefficient is positive, so it's going to be in a U shape like this, and this is minus 1, yeah. So let's put this here. We don't know if this crosses something crosses the line or something. We don't know this such things. We just know that at this point where 2 minus 3, 2 minus 3 is here. So at this point the line crosses the curve, and we also know that at 3 minus 1 crosses again. So the line is somewhere here, and definitely the curve should be here. So the curve should be here. So something is happening here. These are the two coordinates that we've got. Alright, it was a little bit messy, but I think we covered everything about quadratics in this series. So with this, therefore, I'm going to close this series. So I hope that, just like me, you've learned enough about quadratics, and that you will be able to um, just to solve any problem concerning quadratics equations. Thank you for watching, and see you next time. Cheers!